Hello! For one last time this unit. This is lesson 9 in unit 4, and today we're going to talk about determining molecular and empirical formulas. So, this is the last lesson in this unit. We have made it through. We've done a lot of math. Not done yet. Next unit's a lot of math too, but you've made it this far successfully. Good job. So, in the last video, we talked about multi-step conversions and going through mole central station. And so today, last topic is how to determine molecular and empirical formulas of a compound. Okay, so before we figure out how to figure out which is which, or how to figure them out, we got to know what they are. So an empirical formula tells us what elements are present, but in the simplest ratio. So if you kind of think of ionic compounds, remember in ionic compounds, we use the simplest ratio. But in molecular compounds or covalent compounds, we did not. If we have, though, the simplest ratio, that is what an empirical formula is. So a molecular formula, so all covalent bonds in a simplest ratio. The molecular formula, though, tells you the elements and the exact number of each. And so that is, kind of the formulas just generally. And just so we're clear, it is possible for the molecular formula to be the same as the empirical formula. So sometimes the two are the same. Not always, but for certain molecules, they are the same. And if not today, in class, you'll see an example of that. Okay, so empirical formula is the simplest ratio. So here is an example, C4H8. When we're going to determine the empirical formulas, we got two steps. One, find the greatest factor, and two, we could can also divide. Also, we could find the greatest common factor. So think, what does 4 and 8 have in common? The GCF, or greatest common factor, is 4. We divide everything by 4, we get CH2. CH2. And so that is your empirical formula. That's it. Okay. So go ahead and try this one. What is the empirical formula of H2O? First, the greatest common factor is 1. And so knowing that, what's the empirical formula? And hopefully you said H2O. Now here's an example of the empirical and the molecular formula being the same. That's totally okay. That is possible. Okay. So, next is what's the empirical formula of this one? Go ahead and try this one. So GCF is 2, so you are P2O5. That is your empirical formula. Again, simplest ratio. So that's the simpler part of this. But now, what if I gave you the empirical formula and wanted the molecular formula? So we're able to do that given a few different things. And so that is what we're going to do in the next thing. Okay, so here is the first question. A compound has an empirical formula of CH3 and a molecular mass of 75 grams. What is the molecular formula? So the problem is here, we could have, this is the simplest ratio. Anything could be, have that same ratio. So we have to figure out what it is. And so we're given the mass of the molecular formula. So that's what we're given. And so next step is to determine the molar mass of the empirical formula given. So we have to find the molar mass of CH3. Molar mass of CH3. So carbon is, we have one of them, it's 12. H is, we have 3 of them, so 1, 12 plus 3 is 15. 15 grams per mole. Okay, So we know CH3 is 15 grams. Our next thing is to divide the molar mass of the compound by the molar mass of the empirical formula. So that's taking this and dividing it by that. So what this is showing us is the mass of the actual thing we're looking for and the mass of the small thing, the small ratio of it. So 75 divided by 15 is 5. And so what that number means, we're not done, is that the molecular formula is 5 times bigger than CH3. So our last step is multiply the subscripts by the in the empirical formula. So C becomes C5, H, 3 times 5 is 15, so we're left with C5H15, like that. So basically we're finding the mass of the empirical formula, figuring out the ratio it got cut down by, and then building it back up. Okay, so here's another one. We got the steps on the side. Let's go ahead and jump into this. So first thing is to find the molar mass of the empirical formula, NO2, and we got one of them, it's 14, plus O, we got two of those, 16, 32, 14 plus 32 is 46. Okay, so we did that. Next is divide the molar mass of the compound by the molar mass of the empirical formula. So, we get 92 divided by 46, which gives us 2. And so we're not done. That just tells us our molecular formula is 2 times bigger than the empirical formula. So we take that and multiply the formula, so we get N2O4. So multiplying that by 2. And that is it. Okay. Lastly, last question we'll do together is what compound has a molar mass of 90 grams per mole and the empirical formula CH2O. What is the molecular formula? So, we're given this, we're given that. Step 2 is to find the molar mass of this. C, we got one of them, it's 12. H, we got two of those, it's 1. O, we got one of them, 16. 12 plus 2 plus 16 is 30 grams per mole. Okay. Next, divide the molar mass by the compound divided by the molar mass of the empirical formula. So 90 grams divided by 30 grams gives us 3. That's done, but we're not done with the question. We gotta take this, multiply it by that. So we get C3H6O3, just like that, and that is your formula. So again, as long as you're following each step, that helps you a lot, and that's pretty much it. So again, this is the last video of this unit. There will be review videos that will come up eventually. Stay tuned for those. But that is it. You have successfully learned all there is to know in this unit. Until next time, bye.